Previously, we've learned how to find the area between a curve and the x-axis, but how do you find the area between two curves, like in this case, all right? So, or in this case, like right here, the shaded region. So what we're gonna look at, okay, is this is gonna be our left endpoint A, and that's where we wanna start finding the area. And then right here, B. And this top function right here, let's call this one y equals f of x, okay? And what we want to do is basically we want to find a rectangle, right? We want to add all these rectangles up, and the rectangle is going to have a infinitesimally small width, all right? Which we're going to call right here, this is dx. Okay, so from right here, from the x-axis to the curve, the function f of x, this is be the height, right? So our function, whatever our function value for f, that would be the height of this rectangle, and the width would be this little itty bitty squished in dx, okay? And so the shaded region here would just simply be from previous, lessons, the integral from a to b of, and then the height of the rectangle would be f of x, and the width would be dx. So that's where we're going to write this as f of x, the height, times dx, right? We're just going to write dx. Over here, this curve right here, let's call g of x. Okay, and let me get the right pen. So this one right here, we're going to call g of x, or y equals g of x. So right here, the left endpoint is going to be A, and the right endpoint is going to be B. And the height of my rectangle this time, this height would be g of x. And this little width right here would be dx. So there's that's a drawing of a really skinny rectangle, right? So this is going to be the integral from a to b of g of x dx. And I should have written here, okay, so the height of this rectangle is f of x over on this one. Okay, so how do you find this region? Well, you can think of it like this. I need to find this region right here, and if I subtract this area, I would get it, right? So the integral of a to b f of x minus integral a to b of g of x dx. Well, couldn't we just get the height just from the distance between these? And that's what it's going to be, all right? So this top curve is f of x. The bottom curve is going to be g of x. And if we subtract these, that's going to be the height of my rectangle, okay? So I'm going to draw one little skinny rectangle in here. What would this be? What would the height of this be? Well, from here to here is f of x, and from here to here is g of x. So if I subtract f of x minus g of x, I'd have the height of this rectangle. So f of x minus g of x. Okay, and again, right here, I'm going to start finding my area right here at A, and then right here at B. And the width of this rectangle is, again, really, really small, so we're going to call it dx. And so this integral to find the area between two curves is simply the integral from A to B of, and a lot of times we're going to use brackets in here, f of x minus g of x, close the bracket. That's the height. That's this new height of the rectangle, and then times the width, which is dx. Now, the height needs to be positive, okay? And in order to make that become positive, we got to take the top curve minus the bottom curve. So really, this f of x is the top. That's why I picked that one, and I subtracted g of x, which is the bottom. So you can think of this as being the top, which is going to be a larger y value, minus the bottom, which is a smaller value. That will always guarantee you have a positive value for your height here. Because when we talk about area, we're talking about the actual area, so we want it to be positive. Okay, we haven't done this yet, but it's coming. All right, we're integrating up and down. with dx. You can also integrate sideways, okay? And to make sure that our heights of our rectangles are going to still be positive, instead of doing top minus bottom, we're going to have to do right minus left. And I'll talk about more on this for the future lesson, okay? We're not gonna have to worry about right minus left today, but it's coming, okay? And why does it need to be right minus left? Because values on the right are larger than values on the left. So, and in this case, it'd be x values. X values on the right, like in this case, b is larger than a. So when we go b minus a, that's gonna give us a positive value, okay? All right, let's jump in and do a problem. So in this case, we have, in this problem, we have let R be the region bounded by the functions f of x, which is negative 4x squared plus 7. Okay, so looking at that, that's a parabola, and g of x equals 3. That's the horizontal line, because y is always going to equal 3. So we know this one right here, this top one right here, is my f of x function. And then right here, this line is my g of x function. So when I go to make my rectangle, right, a representation of my rectangle, I'm going to go from here to here, okay? And so that's going to be my top curve, which would be the f of x curve, and then minus my bottom curve, which is g of x, okay? So this right here will be f of x minus g of x. Okay, so where do I start making these rectangles? Well, I'm going to start making them right here. And I'm going to end it right here. Now, one of the things is don't assume by reading off graphs. Okay, is there a way to come up with these points? And you have to show this on the AP exam. Okay, if they don't tell you and like say, okay, this point right here, they intersect at this point, you're going to have to find this. And to find this, you have to set up a system of equations. Okay, so we know that these are going to equal each other at these 2 points. They're going to have the same x and the same y values. That means this negative 4x squared plus 7 is going to have to equal 3. So that's all you need to write is negative 4x squared plus 7 is equal to 3. And then we need to solve this, okay? So to solve this, I'm going to subtract 7 from both sides. So you get negative 4x squared is equal to 3 minus 7, which would be negative 4. And then I'm going to divide both sides by negative 4. And we get x squared is equal to 1. And then square root both sides. And then the absolute value of x is equal to 1, which means x is equal to plus or minus 1. So since the y is always 3, right, we know this point is 1 comma 3. And we know this point right here is now negative 1 comma 3. Okay, so it's really important that we're going to need to solve equations using our graphing calculators, okay? And this will be for example 3. And you've got to show this step right here. You've got to show this or the whole problem's wrong because you're not showing your work, okay? So it's really important. Write the system that you're solving, okay? And then go ahead and solve it either algebraically like we just did or with a graphing calculator. I'll show you how to do that in a minute, okay? So we have f of x minus g of x, and we want to start these rectangles at -1, and we want to stop making them at 1. So that's going to be the integral of -1 to 1 of, in this case, f of x minus g of x. Please don't think f of x is always the top function. It doesn't have to be. Okay. So then this is going to be the integral from -1 to 1 of, and it's going to be really important that we use parentheses here. My f of x function is negative 4x squared plus 7. So I'm going to use parentheses, negative 4x squared plus 7, and then minus g of x, which is just 3. And then dx. Okay, so that's equal to the integral from -1 to 1, and I forgot there's a square here. So negative 4x squared, right? So when we go to subtract these, this winds up being negative 4x squared plus 4, and then dx, right? And you can put a bracket around this if you wanted to. And now we're ready to integrate this. Okay, so this is going to be equal to negative 4x cubed over 3 plus 4x. And we're going to evaluate this from -1 to 1. So that's going to be negative 4 times 1 cubed over 3 plus 4 times 1. And then minus, and now we got to put negative 1 in. So that'd be negative 4 times negative 1 cubed over 3, and then plus 4 times negative 1. Okay, I'm going to slide this up a little bit. And then this is equal to, and 1 cubed is 1. So this is negative 4/3. So negative 4/3 plus 4, and then minus, and negative 1 cubed, it'd be negative 1 times negative 4. So this is going to be positive 4/3 and minus 4. And then we're going to distribute this because I don't want to actually get a common denominator here because I see I have common denominator here and here. Okay, so this becomes negative 4/3 plus 4 minus 4/3 and then plus 4. And so that gives us a value of negative 8/3 plus 8, okay, which is 8 can be written as 24/3. So this is negative 8/3 plus 24/3, and that gives us an area of 16/3. That's the area between the two curves is 16/3, and we did that all without a calculator. Okay, so my plan right now is to do 2 examples without a calculator for you guys, and then the last example is with a calculator and using technology. Okay, and usually the equations when we do it with a calculator are start to become a little bit harder. Okay, all right, so let's go to the next problem. Okay, so we have 2 parabolas, one that's upside down and one that's right side up, right? So negative x squared, that's got to be this one right here. That's following along right here on the top. Okay, so that's this right here is going to be my negative x squared. So that's g of x this time, right? And then this time the bottom one is the x squared minus 6x. So that's this one right here. So that's going to be f of x. So in this case, when we go top minus bottom, right here, okay, that's a representation of one rectangle. This right here is going to be, instead of f of x minus g of x, it's top minus bottom. So it's g of x minus f of x. Okay, so my heights of my rectangles are always going to be g of x minus f of x. Okay, and then I want to know, where do I start making these rectangles? Well, all the way, I'm going to start right here at this intersection point, and I'm going to stop it right here at this intersection point. So I got to figure these out, right? What's the starting x value and the ending x value? So we're going to set up a system of equations, right? Again, so it's going to be x squared minus 6x. These, where these intersect, these two functions are equal to each other. Equal values method, if you remember from math 1. Okay, so this is going to be x squared minus 6x has to equal negative x squared. I'm going to add x squared to both sides, and then that would give me 2x squared minus 6x is equal to 0. There's a GCF here of 2x, so I'm going to factor that out. So 2x times, and I'd be left with x minus 3 equals 0. And this would happen when x is equal to 0 and when x is equal to 3. Okay, so the coordinates of this point right here is this one's going to be 0, 0. And this one right here is going to be 3. And when I put in here, it'd be negative 9. Okay, now I realize you might be saying, Mr. Mitchell, I could just read that off the graph. Yes, but you got to show this. If you want the points, you got to show this. Okay, you got to show this. You have to. Okay. And my exams. Because if I don't make you do stuff for the AP exam, you know, you're not going to be ready for the AP exam. Okay. All right. So now to set this up, okay, we are going to integrate by hand, and we're going to go from 0 to 3. And this time it's going to be g of x minus f of x. And then dx because our widths are dx still, okay? So this is going to be an integral from 0 to 3 of, and g of x is the negative x squared. So negative x squared, and then minus my f of x, which is x squared minus 6x. Close my bracket, and then dx. I'm going to clean this up a little bit. And that's going to be the integral from 0 to 3 of negative x squared minus x squared plus 6x dx. Cleaning this up a little bit more, this would be the integral from, this is an equals. The integral from, that be careful, because like that could have looked like a negative, right? So that's an equals right there. And then from 0 to 3, and then this would be negative 2x squared, and then plus 6x. You don't have to have the brackets that I'm writing, okay? All right, so then when we start to integrate this, right, this is going to be negative 2x cubed over 3. And then plus 6x squared over 2. And we're going to do this from 0 to 3. Okay, I'm going to clean this up a little bit. So this would be negative 2x cubed over 3, and then plus 3x squared. From 0 to 3. Okay, so we're going to put 3 into this and subtract putting 0 into it, right? So negative 2 times 3 cubed over 3 plus 3 times 3 squared, and then minus negative 2 times 0 cubed over 3 plus 3 times 0 squared. Okay, you need to write this. I won't know that you knew to put it in if you're thinking, oh, I just put 0 in here, right? And I know that's going to be 0, so why even write it? No, you got to show me, okay? Because I don't know, all right, that you forgot it or you realized that was going to be 0. I don't know either one, okay? All right, so once you write it here, like, oh, that's going to be 0, you don't have to write anymore, okay? So 3 cubed would be 3 times 3 times 3. So 3 times 3 is 9. Notice I'm counting on my fingers. 3 times 3 is 9, times 3 is 27. So this is going to be 27 times 2. That'd be negative 54 thirds. Three squared is 9. 9 times 3 is 27. So this is plus 27. And then minus 0, right? So I don't really need to write that. Now, I realize just right now, okay, I could have cleaned this up a little bit because this is 3 times 3 times 3. So one of these 3's cancels with this one, right? So this is really becomes 3 squared, which is 9 times negative 2. This is really negative 18 right here. So that would have made it a little bit easier. So this is negative 18 plus 27. And then we can just combine these. And so we have more positive than negative, right? Our answers should come out to be positive, okay? And so we have 7 and 2, so that's going to be 9, okay? And so the area of that region is going to be 9, all right? For this next problem, we're moving into where we're going to use the calculator, okay, to do our integration. So let R be the region bounded by the functions f of x equals 3x squared minus 5 and g of x equals negative 3x squared plus 10x. As shown in the diagram below, okay, find the area of the region R using a calculator, rounding to the nearest thousands. Okay, so this one right here is the upside down parabola, right? So in this case, this would have to be the g of x. So this one right here is g of x. And I know because it's negative 3x squared, so it's a parabola that's opening down. And both these are parabolas, okay? So right here, this is negative 3x squared plus 10x. So that's my g of x. Okay, and 3x squared, positive 3x squared, that's the right side up, okay? And notice it's going through negative 5, right? Okay, and then so right here, this is my f of x. Okay, so a representation of my rectangles, right, would be this one. And it would be, how I would get the height of that rectangle would be g of x minus f of x. Okay, so now the other thing we need to do is we need to find the coordinates of this point. Now, look, you can't read it off the graph, right? So this one, you'd have to use a graphing calculator, or they would tell you what these values are, okay? If they tell you, like they have a little arrow to it and saying, oh, it's this, the coordinates, this is the x coordinate and the y coordinate, use it, okay? You can use it. All right, so now, okay, we know that these two functions equal each other where they intersect, right? So we should write, we need to write this equation, all right? We're gonna write the equation 3x squared minus 5. And that has to equal the negative 3x squared plus 10x. Okay, how do we solve this? Okay, so I'm gonna let y1 be g of x because that's my top curve. And that will just help me keep, okay, y1 is gonna be the one that I keep on top, okay? So I'm gonna go to my graphing calculator and I'm gonna enter negative 3x squared plus 10x in for y1, okay? And then I'm going to enter this one for y2. So we want to press y equals, and then we want y1 to be, for me, I like it to be the top function, so that would be g of x, and that would be negative 3x squared. So I'm going to type that in, negative 3x squared, and then plus 10x. And always, it's a good thing to go back and just double check to make sure you typed it in right, and then go down to y2. And y2 is going to be the bottom function, which is f of x. So that's 3x squared and then minus 5. Okay, and then what I would do is go to your window. Since we have a graph, I would just set up the window settings so it's the same as what you see on your graph. So like the left, the x min is negative 1.5 and the x max is 3 and the x scale is 0.5. And then the y min is negative 6. And the y max is 10. And scaling by ones. So that's good, okay? Because then you're going to kind of see the full shaded area, okay? And you'll see where the intersection points are. So we'll graph it. There we go. So now we need to find this one, okay? This intersection and this intersection, all right? So like I wrote the equation on the paper, all right, we got to find this, all right? So we're going to press second trace for calc and select number 5 for intersect. And then the first curve, we're going to let it be the blue, y1, and I'm just getting close to this first intersection point. So press enter, and then press enter for the second curve. Guess is just you got to be closer to the one you're trying to find. Press enter. And once it says intersection, okay, you have it, all right? Now, we want to use all of this, okay? So we want to use the whole value. Now we can write negative 0.403, okay? But we want to use all this. So we want to store this number right here, okay? So I'm going to go back to my home screen, okay? And if you press X right now, it's automatically stored as that's the value we found for the X value, okay? So negative 0.403. But see how it gives us more. We want to use all of these. The problem is the next intersection point that we find using this, we're going to lose that. Okay, so to keep it, we need to store it. So I'm going to take X and I'm going to store it. So right next to the one is store. And I'm going to store it as A. So it's going to be the left one. So I go in alphabetical order from left to right. So A, and then the second one is going to be called B. Okay. So I'm going to call this alpha and then A. Oops. I don't think I pressed alpha. Hold on. Okay. If that happens, just go back over it and okay. So alpha A. There we go. Okay. And press enter. Okay. So now if I press A, okay. So I pressed alpha and then math to get the green A. And if you press enter, A is stored as that number now. So every time we type A, it's really this number right here. Okay. So A and this number are 1. All right. Now, the reason we want to do that is because if we go back and find the next intersection, okay, we would lose that X value. The X is going to be something different now. So if we go back to the graph and we find this intersection right up here, that's 1, 2, 3, 4. It's a little bit more than 4, okay? If we press second calc and we select number 5, intersect, and I'm just going to move over closer to that one we're trying to find. And then press enter, and then press enter, and we're close to it, so right there. All right, so now if I go back to the home screen, my x is going to be this value down here at 2.0693664. And again, we want to use all of that. So I'm going to press second quit. And if I press X, see, now it's that number, that second number, okay? That's why we need to store it as A. So this one is the one on the right, okay? So I'm going to store it as B. So I want to take my X, I want to store it as alpha and B. So that's going to take the X value and store it as B. And now every time I press B, it'll be that X value and it won't change on me, okay? All right. Okay, so now, okay, we found the intersections, okay? So now we're going to go back and we're going to find the integration. So from this, we got for an answer, X is approximately negative 0.403. Okay, and I showed you on the calculator, we need to store this as A. So we can write this on our paper, but we're actually going to use the entire number value, okay? And our other answer to this is 2.069, okay? So it's fine if you write only to 3 decimal places, right? Because this keeps going, okay? This is my A and this is my B value from how I showed you how to store it on the calculator, okay? So now when we go to write our integral, all right, we're going to integrate this starting at this negative 0.403. But again, I'm going to say this, you're going to get sick of me saying this. We're actually going to type into our calculator, not the negative 0.403. We're going to type in A because that will give us all of the digits, okay? It will give us way more digits than we need, okay? And then up here, the upper limit is going to be 2.069. Okay, and then it's going to be our g of x function minus our f of x function. And then dx. And then this would be equal to the integral from negative 0.403 to 2.069. And if you wanted to, you know, we can write in bracket and then our g of x, which is negative 3x squared plus 10x. I'm using the brackets for my integral, and I'm using parentheses for the individual functions. So then minus, and then parentheses, 3x squared minus 5, and then close the bracket, and then dx. For this problem, it's actually pretty easy to combine these. If it wasn't, then I would just do like, this is my y1 minus my y2, okay? So then this is equal to the integral from negative 0.403 to 2.069. And this is going to be negative 3x squared minus 3x squared. So that's going to give us negative 6x squared. And this is going to be plus 10x. And then plus 5. So I did this, I cleaned this up, but you wouldn't have to, okay? A lot of times you're not going to want to because it's just too complicated. But I actually, because they were both parabolas and they were easy to subtract. That's the only reason, okay? All right, so we're going to go to our graphing calculator. We're going to put this in. Again, we're not going to put in negative 0.403. We're going to put in A because A is the entire, all the digits, okay? And then B here, okay? So let's go to our graphing calculator and we'll do that. So now we want to do the integration, all right? So we want to press alpha and then window and then select number 4 for integration. And okay, we do not type in the number we wrote. So don't type in negative 0.403 for your lower limit and your upper limit 2.069. You will be wrong. It will be counted wrong on the AP exam, okay? Because you don't have enough digits. That's why we stored A as this negative 0 point. So we're going to, instead of having to type the number, we're just going to type alpha A and then alpha B. It's okay to write the number, but just don't use that number, okay? And then we simplified it, right? So negative 6x squared and then plus 10x for my integrand, and then plus 5. And then dx. And press enter. And we get 15.107. So, okay, so that's our answer, 15.107. But I also want to show you that we could have done the same thing, and instead of simplifying it, we could have gone right to, and I'd be fine with this, is if you wrote alpha window, and we're going to integrate again. I just want to show you it's going to be the same value. If we go alpha A to alpha B, and to find this area, it was y1, so alpha trace 1 for y1, and then minus alpha trace 2 for y2, and then over here dx. Okay, and if we press it, look, see how we get the same value. So even though I simplified it, that's fine, but you really don't have to, okay? You could have gone right to this. Now, we can't use calculator notation, so you can't use y1 and y2 when you write it down. You have to write, g of x minus f of x, okay, the correct functions, okay? But to type it in your calculator, you could type it this way and you get the same answer, okay? So from our graphing calculator, we got a value of 15.107. And that's what we want to, we want to go to 3 decimal places, okay? On the AP exam, they require you to round to 3 decimal places. They won't tell you to round to the nearest thousands. You just need to know that, okay? On these problems, it does tell you, okay? All right. So, okay, a few things. When you got to determine which is the top curve and which is the bottom curve, right? If you're solving a system with a graphing calculator, like if they're not nice values, right? Like you looked at the last 2 examples, you could look at the graph and go, oh, it's going to be this, all right? But there's no way that you can read these off the graphing calculator, okay? You want to set this one for one of them to be your y1, the other one to be y2, and then you can write the 3 decimal places, but you don't want to use the 3 decimal places in any other calculation. You want to use the full stored value, okay? All right, and that's it.